Yes, hello everyone, welcome my dear students. Everyone, welcome you all to CBSE's first personalized chapter model tuition. So we'll check out some major questions, major concepts of light reflection. Ajisa, you can open the YouTube comment section, so if anyone is dropping a comment, I can check it out. Yes. So whatever the concerns, queries you have, you can comment in the chat box, guys. So what we are gonna do is, you all know that the grade 10 light chapter is a whole series, right? Over there, what happens? We have major two topics, that is none other than reflection and refraction. So when it comes to reflection, there are certain concepts which is very important for us. So what will we do? We'll check out the important concepts of the reflection part. Got it? So refraction, we'll do it later on. So one shot of refraction will come on the way. So right now we are going to do the one shot of reflection concepts. So over here, what we'll be discussing? Important majority equations, majority concepts, and important questions of reflection of the light chapter in grade. Got it? So whatever the concerns you have, you can drop a comment in the chat box. I'll be there to support you all. So let's begin. I hope you all are ready over there. So with respect to chapter light reflection concept, let's check it out. So any concerns, guys? Can we start? Are we good to go? Are we good to go? No concerns, right? I hope you all are power packed over there. So we can start. Nothing special, right? So yes. So let's check out some important concepts of the light chapter, guys. So when it comes to the grade 10 syllabus, the major chapters coming up is light, reflection, refraction, human eye, electricity, magnetic effects. So in physics, these are all the major 4 chapters which you have in grade 10 physics. So have a look at it. So with respect to light, reflection, and refraction, we have important topics. So when it comes to reflection part, obviously you have to learn the different image formation of spherical mirrors, and you have to learn the different terms of it, such as center of curvature, principal axis, principal focus, focal length, mirror formula. So the derivation of mirror formula is not needed, and the magnification concept. So the concept which are tabulated over here is very important when it comes to the reflection concept as well as refraction. Refraction part, we'll check it out. Got it? So with respect to spherical mirrors and lenses, why I'm teaching both the equations over here? Have you ever thought about it? Because this is a reflection concept, right? We don't have to check both the concepts. Why I am discussing both the equation over here? Because we can compare and study the equation. Got it? That is the reason I am comparing it. That is, whenever you consider the equation of mirror, learn the equation of lens as well, so that you won't forget it later on. You can compare and study it. Clear, guys? Yes. So when it comes to mirrors, we have the equation 1 by f is equal to, we can consider 1 by f is equal to 1 by v plus 1 by u. That is the mirror equation. It is plus, right? 1 by v plus 1 by u. But when it comes to the lens equation, the game is different. When it comes to lens, it is different. The game is different. That is, so in the case of mirrors, it is 1 by f is equal to 1 by v plus 1 by u. In the case of lenses, it is 1 by v, f is equal to 1 by v minus 1 by u. See the difference in sign over here. You might have noticed over here. The signs are different, right? Isn't it? So sign will be different over there. So that is the major difference we have over here when it comes to the mirror and lens equation. So you should have a basic idea about it. Got it, guys? And guys, do you know what is this f, what is v, what is u? You will have a basic idea, right? So for your information, I'll write over here. So f is none other than the focal length of a mirror and lens. So it is the focal length. Focal length is f. When it comes to v, it is the image distance. V is the image distance, whereas u is the object distance. And guys, do you know what is an image distance? Image distance is in the case of mirrors, the distance from where to where? Any idea? Image distance is actually the distance from the mirror to the image. Got it? And object distance is the distance from the mirror to the object. In the case of lens also, it will be like, it is the distance from the optic center of a lens to the image. In the case of object, the distance from the optic center to the object. It goes like that. In the case of mirrors, instead of optic center, it will be pole of the mirror. Pole will be there. Okay, so each parameter when it comes to image formation of mirrors and lenses, we'll check it out. Okay, I'll show you the major terms. Yes, so terms associated with spherical mirrors, guys, very important, because you'll not have direct questions write everything, but there'll be 1 mark question, and you should know these are the basics. That's right, basic things which you need, which is very important. So when it comes to image formation, you will have a lot of terms coming up on your way. So the first one is none other than the center of curvature. So I'm considering the center of curvature. When it comes to center of curvature, it's the center of a sphere. So whenever we are considering a mirror, it's actually the center of a sphere, right? The case of a lens also, it'll be the same. That is, we'll be considering the center of a lens, isn't it? So since it's reflection, we'll consider only the mirror. So we'll consider the center of a sphere. So this point, the center of a sphere of which the mirror is a part, is called the center of curvature. Got it? So so if you're considering it as a whole sphere, if you're taking one part of it as a mirror, the exact center of that particular sphere is the center of curvature in both the cases, convex or concave mirrors. Now, Paul, that is midpoint of the reflecting surface of the mirror. So let's say this is, what kind of mirror is it, guys? This particular mirror, what kind of mirror? Its reflecting surface is inside, right? This is the concave mirror, isn't it? This is the non-reflecting side. So this is the reflecting side. So it is a concave mirror. So center of a concave mirror is this particular point, that is Paul. That is called as the Paul. That is the midpoint of the reflecting surface. So in this case, this is the midpoint of the reflecting surface. This is the Paul of this convex mirror. Got it? So midpoint of the reflecting surface, it is marked as P over here. That is the Paul of a mirror. And next we have the principal axis. Principal axis means what? It is the axis which connects the Paul and center of curvature of a mirror. This particular line from the Paul to the center of curvature, this dotted yellow line, you can see, right? This is the principal axis of a mirror. So this is also the principal axis of a mirror. So when you draw diagrams of image formations, it will be like this. You'll be drawing a concave mirror like this, and this will be the Paul of a mirror, and this will be the center of curvature. So this particular line which connects the center of curvature as well as the Paul of a mirror is called as the principal axis. As simple as that. Easy, learn, done and dusted, isn't it? Yes. After that we have the radius of curvature. After that we have radius of curvature. So diagram question will come in exam. Yes, Avi Kashyap. Diagram question will come for exam for sure. There is a lot of image formation diagrams are coming up on your way. Direct questions will be there. Got it? Yes. So this is how we'll consider the principal axis. Next we have the radius of curvature. What is the radius of curvature? So we have learned this point is called the center of curvature. Okay, we all know it. That is the center of a sphere. But when it comes to the radius of curvature, what can we do, guys? What should we do? What can we do? We have to consider the distance from the Paul of a mirror to the center of curvature. This distance is called as the radius of curvature. Correct? This measurement from the Paul of a mirror to the center of curvature. Let's say from the Paul to the center of curvature, it's 10 centimeter. Got it? So the radius of curvature is 10 centimeter. Understood? From here to here, this distance, let's say it is 5. So what can we say? The radius of curvature will be 5 centimeter. Got it? It is actually the radius of the sphere. Got it? So radius of a sphere of which the mirror is a part is called the radius of curvature. And the next one is none other than principal focus. That is, over here we have the Paul and center of curvature, right? At the exact middle of the center of curvature and the Paul, we have the principal focus. Let's say the radius of curvature is 10 centimeter. Then we will have the principal focus at 5 centimeter. That is just the half of it. And what do we have at the principal focus? That is the point where all the rays will meet, or it will appear to meet over there at the principal focus, so that the image will be focused over there. Got it? So it is called as the principal focus of a mirror. So everyone note down all the major terms associated with spherical mirrors. So once you're done, let me know. Note it down real quick. Note it down real quick. Yes, Avi Kashyap, I am seeing your comment. Avi Kashyap is watching it. Seriously, I guess. Very good, Avi. Yes. Diagram questions will come, guys. That's why I said the terms associated with spherical mirrors will be very helpful for you all. Got it? So you have to learn how to draw the extension over here on screen. I want more extension. Can you place the camera a little bit to the left? My hand gets cropped quick. So everyone done? Once you're done, let me know so that I'll move forward. Yes, better. So can we crop it more? Check. More is available or not. Very less space. Guys, done writing, everyone. So I guess you can we can move forward. Yes, better. Yes. So I'm moving forward, guys. Yes. Now I have good space. Yes. So if you are done writing the terms associated with spherical mirrors, let's check out some important multiple choice questions. So laws of reflection hold true for, what do you think, guys? Laws of reflection hold true for? True for everything? Only one? Only plane mirrors? Only concave mirrors? Only convex mirrors? Or all reflecting surfaces? What do you think, guys? Laws of reflection hold true for all reflecting surfaces, right? It is universal, right? Isn't it? Laws of reflection hold true for all reflecting surfaces. That is option D is the right answer, chat box. Got it? All the reflecting surfaces, it is applicable. So make sure you remember this. It's not only for plane mirrors, it is for all the reflecting surfaces. Very good, Balkrish. Balkrish is watching it. Very good. Done, sir. Rio is D. Lucifer is saying the answer. Lucifer, very good. Rio is also answering the correct answer, option D. That is all reflecting surfaces. Very good, guys. You guys have just entered grade 10. Still, you're already on track. That's great to know. Fine then. So next multiple choice question. Let's see how many of you answer it. Okay. In the YouTube, I thought less comments will come. No one will answer. Now what can I see? Everyone is actively answering. So everyone drop a comment. Let me see how many of you know the answer of this. How many of you have learned this in school? Because in your school, this first chapter is already covered, right? So the question is, an object is placed in front of a convex mirror at infinity. Okay. So let's say I'm considering a convex mirror. Okay. So object is placed at infinity. Over here we have the object. Okay. The question is, according to the new Cartesian sign convention, that is image formations you might have learned, right? Isn't it? So sign of the focal length and sign of the image distance in this case are respectively. If we are considering a convex mirror, so what will happen to the principal focus, guys? The actual light rays will get deviated like this, right? Isn't it? This ray, if you are considering, will get deviated like this, right? Isn't it? So what will happen? Imaginarily we'll get the image always behind the mirror, right? Isn't it? Image will be formed behind the mirror. In the case of what? In the case of convex mirror. Only in the case of concave mirror, we have all the images formed in front of the mirror. Isn't it? So will we have a principal focus on the left hand side? No, it will be obviously on the right hand side. We'll have the principal focus on the right hand side. So focal length will be positive. So first question, what is the sign of the focal length in the case of convex mirror? If the object is placed at infinity, if we are placing at infinity, wherever you keep the object, the focal length will be positive in the case of convex mirror. So first one we got it as positive. Now sign of the image distance in this case are respectively. Where do we get the image, guys, in the case of convex mirror? In all the cases, in the case of a convex mirror, I hope you remember what will happen. Always we have a virtual and erect and diminished image. Virtual and erect image, where will we get? Will we get the virtual image in front of the mirror? No, right? It will be always behind the mirror. So what will happen, guys, in this case? Image distance will also be positive. Focal length will also be positive. So positive, comma positive. Option D is the right answer. How many of you have commented option D? Shritik has commented positive and positive. Very good, Shritik. Rio has commented option D. Very good, Rio. Rio and Shritik got the answer. Yes. So let me go ahead, guys. Now, when an object is kept within the focus of a concave mirror, an enlarged image is formed behind the mirror. So this image is, what do you think, guys? What do you think? What do you think? Let me see how many of you answer this perfectly. When an object is kept within the focus of a concave mirror, that is, we are considering a concave mirror, okay? So the non-reflecting surface I am marking. So guys, if you don't know what are these spokes, what are these spokes in the mirror? These spokes are called as this non-reflecting side. This is the non-reflecting side. If you don't know, please keep this in mind. If you guys are my new students in grade 10, keep this in mind. These are the non-reflecting surface. Okay. So this is the reflecting side when object is kept within the focus. So guys, let's say this is the focus. This is the center of curvature. So let's say I'm keeping the object within the focus, which means inside the focus and pole of the mirror. Okay. What will happen? An enlarged image will be formed behind the mirror. We'll get an enlarged image behind the mirror over here. Isn't it? Obviously, we'll get an enlarged image over here. Isn't it? So, the question is, the image is real. Guys, will we get a real image behind the mirror? No, right? We'll not get a real image behind the mirror. And this image, do you think it is inverted? Inverted means what? Heads down, legs up. Isn't it? Upside down. So this image is not at all inverted, right? It is obviously erect itself. So image is not real, not inverted. So it is obviously vertical and erect. So vertical and inverted is also wrong. Rio this time gave a wrong option. Later he has corrected. Very good, Rio. Rio first answered option C. Later he realized. Yeah, vertical and erect is not inverted. So it is option C. Isn't it, Rio? Hannah has also commented this time the correct answer. Hannah is also already on the league, isn't it? I thought only few students are fighting for the correct answer. So Hannah is on track. Very good, Hannah. Hannah has told the right answer, that is vertical and erect. Very good, guys. Yes. Now, in the case of image formation, you might have learned different variety of image formations, right? Isn't it? So for that, so as to remember all that, we have a tabulated data with respect to different positions of the object and different position of the image. Got it, guys? Got it? We have different position of the object. With respect to that, different image formations will be there. So in the case of a concave mirror, so this is the case of image formation. This is the case of image formation. Image formation in a concave mirror. This is the image formation in a concave mirror. Okay. So what will happen, guys? Image formation in the case of concave mirror. Initially, if you keep an object at infinity, what will happen? What will happen if you keep an object at infinity? The image will be formed at principal focus, and the nature of the image will be real and inverted. Guys, if you want me to show an example, I'll show an example. That is, if you are considering a concave mirror, let's say, if you are considering a concave mirror, it looks like a bow and arrow, right? It's not a bow and arrow. It is a concave mirror. So I'm considering an object kept at infinity. Okay, this is infinity. So let's say an incident ray is coming. Okay, I'll take it as white ink, so it'll be better for you all. So let's say I'm considering an incident ray coming parallel to the principal axis. So what will happen after reflection, guys? What will happen? If a ray is passing parallel to the principal axis, after reflection, it'll pass through the principal focus, isn't it? It'll pass through the principal focus, isn't it? And if I'm considering another ray, let's say, if I'm considering another ray incidenting over here at the pole, what will happen? It'll go obliquely, making the same angle. It'll go obliquely, making the same angle. It'll go like this. So guys, what will happen? So you'll be thinking, sir, we are not getting the image over here in the principal focus. So what you have to do is, over here, it is mentioned, if we keep the object at infinity, we'll get the image at f, right? Why in this case, even if we kept the object at infinity, we didn't get the image at principal focus? What is the reason, guys? What is the reason? How should we consider? Then? How will we get the image formed at principal focus? Over here, the initial ray, okay, first we took a ray parallel to the principal axis. That particular ray, okay, we can consider obviously after reflection it will pass through the principal focus. Now, the next ray, which is incident, can we take it through the pole? Can we consider an incident ray incidenting the pole? Will it ever pass through a principal focus? No, right? We won't get an image formed at principal focus. If you are considering another ray which is incidenting to the pole, isn't it? It will never form an image at principal focus. But guys, what is the nature of the image? They are saying it is real and inverted, and the size of the image is highly diminished. So how should we have the rays coming up? If it's from infinity, can we say it will directly incident to the pole of a mirror which is coming from infinity? So this is a lesson that you should never take a ray coming from infinity like this to the pole. That is wrong. You can consider it like this: if a ray is coming from infinity, if you are considering another ray parallel to the principal axis, it will pass through the principal focus itself. Whatever happens, all the rays coming from infinity, what will happen? It will be parallel to the principal axis always. So why I'm not taking it like this? Because object we are not considering it as inverted, or else if a ray is coming from infinity like this, still it will go through the principal focus. So all the incident rays coming from infinity will pass through the principal focus, and what will happen? What will happen, guys? A highly diminished image will be formed over here. Got it? A highly diminished image will be formed over here. Got it? If you are considering a ray passing through the principal focus, what will happen after reflection? It will pass parallel to the principal axis. Got it? If you are considering a ray which is incidenting to the pole, after reflection, what will happen? It will go obliquely, making the same angle. Got it? So make sure you remember it. So in the case of concave mirror, in all the cases, if the object is at infinity, the image will be formed at principal focus. In the case of beyond C, what will happen? The image will be formed between C and F. So that is the one, that is the error we had over here in this case. That in the case of beyond C, you can consider C. Let's say you are considering the object beyond C. Okay, so in this case, what will happen? You can consider a ray incidenting parallel to the principal axis and another ray passing through the incidenting the pole. In this case, it will work because this ray will go like this after reflection. This ray will go like this, isn't it? After reflection, it will make the same angle. Where will we get the image? We'll get the image over here. Since I'm drawing it freehand, it is moving a little bit. If you draw it with proper measurement and scale, what will happen? Exact image will be formed between C and F, and you will get an inverted image over there. Since I'm drawing it freehand, the position is changing a little bit. So when you draw it with a ruler, a perfect diagram when you're drawing, you will get the image exactly in between C and F if we're keeping the object beyond C. That is beyond center of curvature. Got it? And what kind of image is it? It is a real and inverted image. Why? Because the image is formed in front of the mirror, right? This is the front side of the mirror. You're getting the image in front of the mirror, so it is real and inverted. What will be size? Size of the image will be diminished. So if the object is at, let's say the height of the object is 6 centimeter, the height of the image will only be 3 centimeter, 2 centimeter, 1 centimeter, like that. So very less comparatively. So what will happen? The size of the image will be diminished, and the nature will be real and inverted. Got it, guys? Understood? Yes. If the position of the image is at C, the position of the object is at C, the position of the image will also be at C. For sure, size will be same size. Position of the object is between C and F. Position of the image will be beyond C. If the position of the object we are considering it at F, the position of the image will be at infinity. Position of the object, if it's between P and F, the position of the image will be behind the mirror. That is the exceptional case. Only exceptional case which we have in the case of a concave mirror is this case. That is, we took an example right over here. That is, if we're keeping the object within the focus, what will happen? I'll show you how will we have the ray diagram. If we have a ray like coming like this, it will pass through the principal focus like this, right? If another ray is passing through the incidenting the pole, it will go like this, right? That's right. So will we have a proper image formation? No. So this ray will not go like this. this ray will go parallel. Not parallel, it will go like this. So what will happen? This ray will come and join over here. So the actual image will be formed behind the mirror. That is only in the last case. That is only in the sixth case, which is exceptional case. Got it, guys? And there is a technique to remember all these 5 cases. So when it comes to the size, guys, when it comes to the size of the image, the first case it is highly diminished, very point sized image will get. Second case it is diminished a little bit. Okay, so size is increasing, so inverted image, so I'm drawing it downwards. Now it's the same size, better. Now it's enlarged, size has increased a bit, so you can draw a longer arrow. Now highly enlarged, much longer. This one is virtual and erect, so it is enlarged, but it is an erect image, so you can draw an arrow like this. So when you draw the table, when you study this table, mark it like this. So size you can remember this way. Got it? And try to memorize. In all the 5 cases it is real and inverted. Only in the 6th exceptional case it is virtual and erect. Got it? And when it comes to the position of the image, over here we have the position of the image, position of the object. So this comparison you can do it using a ninja technique. I'll show you the technique. That is, if you are considering a ray diagram like this, let's say you are considering a ray diagram like this. Let's say this is the concave mirror, this is the principal focus, this is the center of curvature, and over here we have infinity. So let's say you're keeping the object at infinity. That is number 1 I'm putting. Where will you get the image, guys? You'll get the image at principal focus, so this is number 1. If you're keeping the object beyond C, where will you get the image? You'll get the image between C and F. That's right. If you're keeping the object at C, where will you get the image? You'll get the image at C itself. If you're keeping the object between C and F, where will you get the image? You will get the image beyond C. Beyond C, you will get the image. If you're keeping the object at F, you will get the image at infinity. Isn't it? So you can memorize it like this: 1, 2, 3, 4, 5 and 1, 2, 3, 4, 5. That is, number 1 is for object keeping at infinity, image formed at principal focus. Object beyond C, image between C and F. Object at C, image at C itself. Object between C and F, image beyond C. Object at F, image at infinity. So this 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 technique will help you to memorize where will the image be formed if you keep the object at infinity or at C and all. So all these things you can memorize using this ninja technique. So please don't forget this in the one shot, guys. Take this into consideration. It'll help you a lot. I hope you're thorough with this table of concave mirror. Now we have the case of a convex mirror. So in the case of convex mirror, you can compare and study concave and convex. In the case of convex mirror, in all the cases, the nature of the image will be virtual and erect every time. And the size of the image will be diminished always. First case, if it's at infinity, it is highly diminished. In other case, it is normally diminished. So make sure that you memorize the image form will be diminished for sure and the nature will be virtual and erect. Positioning, you don't have to worry because in all the cases, the position of the image will be behind the mirror itself. It will never form an image in front of the mirror. Always behind the mirror. Got it? I hope it's clear. Now let's check out this question. A student has focused the image of an object of height 3 cm on a wide screen using a concave mirror of focal length 12 cm. If the distance of the object from the mirror is 18 cm, find the values of the following: distance of the image from the mirror, height of the image. So everyone try it out real quick. Rio, Hannah, Shritik, Lucifer, Avi, Kashyap, everyone, Balakrish, everyone try this numerical. Let me see how many of you get the answer. So once you get the answer, let me know. I'll give you 1 minute to do this. Then we can do it together. Got it? So do it real quick. I'll just write the values which is given over here. So the question is, a student has focused the image of an object of height 3 cm on a wide screen using a concave mirror. That is the major takeaway in this question. It is mentioned that it is a concave mirror. So we know that the focal length of a concave mirror is always negative. So we can write the focal length which is given over here, f is equal to minus 12 cm, because focal length always negative. Right? Not always. In this case, in the case of concave mirror, always negative. So focal length of concave mirror, it is negative, so minus 12 centimeter. So we took this value. And the height of the image of focused the image of an object of height 3 centimeter, that is height of the object HO is given, that is 3 centimeter. Height of the object, let's say if I am keeping an object over here, the height of this object is 3 centimeter. Got it? Now, if the distance of the object from the mirror is 18 centimeter, that is from the mirror to the object, the distance is none other than 18 centimeter. So object distance U we got already. So what is the value of U? It is 18 centimeter. Guys, is it plus 18 or minus 18? Obviously negative 18 centimeter, right? Why? Because in the case of convex mirror or concave mirror, in all the cases, object distance we will always consider it as negative. Why? Because conventionally, what will we do? We'll always keep the object on the left hand side of the mirror. Got it? In the case of lengths also, we'll consider the object on the left hand side. There is a convention. Why? Because when you are learning something, there should be some reference, right? If the reference is not there, we'll be confused with the concepts. Got it? So in practicals, when you do it, you can keep the object on either side. But conventionally, when you draw ray diagrams of mirrors and lenses and all, what will you do? Always you will keep the object on the left hand side. So object distance in all the cases it will be negative. Okay, Shrutik has commented the answer. Very good, Shrutik. So we'll do it. Yes, we'll check it out. So object distance is given minus 18. Image distance is not given, that we have to find out, because find the value of the following. That is the first one, distance of the image from the mirror. So focal length is given, object distance is given. So can we find out the image distance of a mirror? Easy, right? We can use the mirror equation. That is 1 by f is equal to 1 by v plus 1 by u. So we have to find out the value of image distance. So 1 by v we need to find out. So as to find out v value, we can rearrange the equation. That is 1 by v is equal to 1 by f minus 1 by u. So this one we can rearrange and write 1 by v is equal to u minus f divided by u into f. Isn't it? Cross multiplication, 1 into u is u, 1 into minus 1 into f is f divided by u into f. So when you take the reciprocal, you can write, what you can write, guys? You can write, when you take the reciprocal, v is equal to u into f divided by u minus f. So u is minus 18 into f is minus 12 divided by u minus f. U is minus 18 minus f is already minus 12. So it is minus 18 minus minus 12. Got it? U into f is minus 18 to minus 12. U minus f is minus 18 minus minus 12. So it will become plus. Okay? Calculation part. Don't make a mistake. So first we'll do 18 into 12. 18 into 12. When you do it, you will get 216. So the value of v is equal to plus 216. Why? Because minus 18 into minus 12. So it is obviously positive, right? So positive 216 divided by minus 18 minus minus 12 means minus 18 plus 12. Isn't it? So minus 18 plus 12 means how much you will get? You will get negative 6, right? Minus 18 plus 12 will be minus 6. So 216 divided by 6 will be 36. So the v value will be minus 36 centimeters. So focal length is 12 and object distance is 18. So we are keeping the object at where? We are keeping the object between C and F, right? Isn't it? Because focal length is 12. So center of curvature will be 24. But object distance is at 18. So we are keeping the object between C and F. So where will we get the image? We'll get the image beyond C, right? Got it? Shrutik, image is not between C and F. We'll get the image beyond C. Please don't forget it. Yes, negative 36 centimeter. Very good. Correct. So we'll get the image beyond C. Image will not be between C and F. We'll get the image beyond C. Because focal length is 12, right? So center of curvature will be at 24. Got it? So image distance, if it's 36, it is beyond C. Clear? Yes. Now we got the image distance. So first question's answer, we got it as minus 36 centimeter. Now height of the image, HI they are asking. HO is given over there. So guys, based on magnification concept, that is this one I am rubbing. Based on magnification concept, we can write magnification m is equal to minus v by u in the case of mirrors. In the case of mirrors, it is minus v by u. In the case of lenses, it is plus v by u. Got it? So magnification m is equal to minus v by u in the case of image, mirrors. So that is equal to HI divided by HO. Guys, HI is actually height of the image. Okay, HI means height of the image, whereas HO is the height of object. Okay, HO is the height of the object. Okay, so based on that, we can do, based on the magnification equation, I can write HI by HO is equal to minus V by U. From this, we have to find out HI, right, height of the image, because all the other values we know it, minus V by U, HI and all we know it. So HO we know it, so HI is equal to minus V by U into HO. This HO will go to the other side. Got it, guys? Understood? So what can we do? We can write HI is equal to minus V. What is V value, guys? Minus 36, right? Minus 36. So minus V means minus of minus 36 divided by, what is U? U is minus 18, right? It is minus 18 centimeter. So minus 18 into, what is HO? HO is 3 centimeter, right? Isn't it? So it is into 3. So you can consider minus of minus 36 means plus 36 minus 18 divided by minus 18 into 3. Isn't it? So 18 and 3 you can cancel, right? 18 and 3. In 18, how many 3s are there? 6. So 36 divided by minus 6, how much you will get, guys? In 36, how many 6s are there? How many? 6, right? Isn't it? In 36, how many 6s are there? 6 6s are there. 36 divided by minus 6 is minus 6 centimeter. So height of the image HI is equal to minus 6 centimeter. Got it? Yes. Magnification value will be minus 2, correct? Shritik. HI will be minus 6, right, Hrithik? Plus 6 or minus 6? Guys, over here we have a concave mirror, right? If we are keeping the object between C and F, obviously we will get the image beyond C. And what do you think, guys? The image form will be inverted, right? See, the image formed is inverted. So based on the Cartesian sign convention, if the image formed is like this, inverted, let's say the image is like this, so it is negative, right? It can't be positive. If it has to be positive, it should go erect. Got it? So over here, the value of the height of the image should be minus 6 itself, because the image we are getting is inverted. Yes, very good, Shritik. It is minus 6, correct. Hannah has commented positive 6. Later she has deleted. Message retracted. Isn't it, Hannah? But Hannah tried it. Very good, Hannah. I appreciate it. Yes. Shruti got the answer. Very good, guys. Fine then. We'll move forward. I'll give you the next question. Yes. In the following cases, a ray is incident on a concave mirror. In which case is the angle of incidence equal to 0? What do you think, guys? In which case the angle of incidence is equal to 0? In which case the answer, we can find out in which case, guys, is the angle of incidence has to be equal to 0. Guys, you will get 1 minute to think, not more than that, or else I will answer. Quick, make it quick. Shiv is commenting the answer might be option B. Shritik is commenting if it's incident on the principal axis. Okay, we'll check out. So in the following cases, a ray is incident on a concave mirror. In which case is the angle of incidence equal to 0? What do you think, guys? In which case? So first option. First we'll consider a concave mirror. Okay, I'm considering a concave mirror. Over here we have a concave mirror right now. Okay. So what will happen? A ray is incident on a concave mirror, in which case the angle of incidence is equal to 0. That is, if you have a ray parallel to the principal axis, that is the first case. If you have a ray parallel to the principal axis, what will happen, guys? what will happen? The ray parallel to the principal axis will pass through the principal focus, right? It will go like this. Will we have the angle of incidence 0 over there? No, right? Over here, if you are considering a surface, the angle of incidence will not be 0 over there, right? Isn't it? Now, second case, a ray passing to the center of curvature and incident obliquely. So, if I am considering a ray, in the case of a concave mirror, principal focus and center of curvature, a ray is incidenting through the center of curvature and incident obliquely, that is, it is making a particular angle. What will happen, guys, to this particular ray? It will go back through the same path, right? So, with respect to the incident ray, it will go back through the same path. In the case of center of curvature, do we have an angle of incidence over there? If the ray is reflecting, if it's tracing the same path back to it, do we have an angle of incidence over there? No, right? Badra Nair is commenting. Very good, Badra. It is obviously option B for sure. Isn't it? Hi, Shivanya. Okay, Shiv is like, sir, it's Shivanya here. I do remember you, Shivanya. Yes. So it is obviously option B, right? A ray passing through the center of curvature and incident obliquely will trace back the same path. So in this case, the angle of incidence will be equal to 0. So guys, if you have a doubt, you can check out the remaining options as well. A ray passing through the principal focus and incident obliquely. If you're considering a ray which is passing through the principal focus, let's say we have a ray over here passing through the principal focus. What will happen, guys? It'll have an angle of incidence over here. Why? Because if you're considering a normal O, you'll obviously have an angle of incidence. Why? Because the incident ray, if it's passing through the principal focus, after reflection, it'll pass parallel to the principal axis. So this option we can't take, this one we can't take. And the last one, a ray incident obliquely to the principal axis at the pawl of the mirror. So if I'm concave mirror has become under, I guess. Yes. So see, over here if I'm considering a concave mirror like this, and let's say this is the pawl of the mirror. Let's say an incident ray is incidenting the pawl of a mirror. It'll go obliquely like this. Still there will be an angle of incidence. See, over here proper angle of incidence and angle of reflection is there. So in this case also the angle of incidence will not be equal to 0. So in all these three cases will not be equal to 0. Only in the second case where a ray is passing through the center of curvature and incident obliquely. Obliquely means it will make an angle. So obviously it will go back through the same path. So option B is the right answer. Yes, Shritik, he understood right now. Great, Shritik. So fine, then we'll move forward. I hope you got this question. So next one. If the image formed by a mirror for all positions of the object placed in front of it is always erect, okay, and diminished, what type of mirror is it? What do you think, guys? If the image formed by a mirror for all positions of the object placed in front of it is always erect and diminished, what type of mirror is it? Let me know real quick. Let me see how many of you answered it right, how many of you answered it perfect. Over here we have the image formed by a mirror for all positions. It is none other than, it is always erect and diminished. In which mirror, sorry, I'm not drawing the mirror over here. In the case of this mirror, we'll have the image formed always erect and diminished. You have learned it. Very good, Shivanya. It is none other than the case of a convex mirror. The case of convex mirror is always erect and diminished. We have learned it already. I hope you remember this. The image formation in the case of convex mirror, please don't forget, guys. Very, very important. So the answer is none other than a convex mirror. Please do keep this in mind. Convex mirror always forms a virtual erect and diminished image of the object placed at any position in front of the mirror. So please do keep this in mind. It'll help you a lot. Yes, correct Shritik, correct Shivanya, correct Hannah, correct Badra. Every single student in my class is commenting it right. So let me know if you're done. We'll move forward. Obviously convex, right? As we have learned, case of convex mirror, the image form will be behind the mirror in all the cases. So what kind of image will get behind the mirror? Always virtual and erect, right? And size of it will be diminished for sure. So if in the question, if it's given as in all the positions, the type of image formed is erect and diminished, it is none other than a convex mirror for sure. Please don't forget this. Okay. Then what else? Yes, this is the case of concave mirror, image formation. In the case of concave mirror, we have learned it already, so I'm not discussing it again. Now, examples, guys. Examples or usages of convex and concave mirrors, very, 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 very important. Got it? So the question is, name the type of the mirror used in the following situations. So in all the cases, what kind of mirror we need? We need to learn this. Headlights of a car. What kind of mirror, guys? Headlights of a car should converge all the light rays, right? So keep this in mind if you don't know. A concave mirror is termed as a converging mirror. Converging mirror. Okay? Whereas a convex mirror, don't write just concave and convex, write mirror as well, or else you will get confused. Concave mirror is equal to converging. Convex mirror is actually diverging. Keep this in mind, guys, please don't forget. So headlights of a car, all the light rays should focus on a particular beam, right? Light beam, right? So headlights of a car will have concave mirror for sure. Concave mirror, isn't it? Obviously concave mirror. Side or rear view mirror of a vehicle. Guys, rear view mirror of a vehicle. First one correct. Everyone has commented right. Correct Shivanya, correct Badra, Shritik, Hana. Concave mirror. Now tell me, side or rear view mirror of a vehicle. Which mirror we should use for side or rear view mirror? In case of vehicles, what do we do, guys? So Badra has commented option B, question B also it is concave. What do you think, guys, remaining students? For option B, for question B. Shivan is also saying it is concave for side or rear view mirror of a vehicle. Shivan is also saying concave. Badra is saying concave. Hana is also saying concave. I thought you guys have learned the concept properly. One shot of light reflection. We have learned all this. So guys, which one will give us a diminished image on the mirror? A virtual and diminished image on the mirror. Because we need to have a wider view on a small mirror itself, right? We should get a virtual diminished image on the mirror because all the traffic behind the vehicle should be seen on this small mirror. So which mirror should we use? We can't use a concave mirror, isn't it? We need to use a convex mirror to get a wider view. All these views should be focused on a mirror. So it should be convex for sure. So please don't forget this, guys. Very, very important. Side or rear view mirror of a vehicle is not concave. You have commented wrong. Please do correct it. It is not other than a convex mirror. Keep this in mind. Very, very important. Why? Because lot of examples have been asked in board exams. Great job. Very important. Okay. So these examples you should never forget. Now, solar furnace. So guys, in the case of solar furnace, what happens is all the light beams over there, or the light rays or the flames that we have should be focused, right, to a particular point so that the things will be burnt so easily. So in solar furnace, what do we use? We use the light beams of sun, right? Sun rays will use. So in that case, in the case of solar furnace, all the light rays should be focused to a particular point. So which mirror will converge all the light rays to a point? A concave mirror or convex mirror? In the case of option C, question C, what do you think, guys? All the light rays will be focused to a point by a concave mirror or convex mirror? Obviously a concave mirror, right? So in the case of solar furnace, there is none other than a concave mirror. Concave mirror. Yes. Shivanya, yes, concave. What is the confusion? Shivanya is like, huh? Which one, sir? Obviously concave. Yes, in the case of dentist mirror, dentist, everyone knows, right? Dentist will be focusing our each and every teeth, right? So we should get an enlarged image. If we keep the object close to it, if we keep the mirror close to our teeth, then an enlarged image we should get. So guys, do you remember in the case of concave mirror, there is a last case. If you keep the object between P and F, that is close to the object, if you are keeping the mirror, we'll get an enlarged image, isn't it? So we should use a concave mirror in the case of dentist. Concave. Dentist will use a concave mirror. Got it? So I hope you remember all these examples. Now, why do we prefer a convex mirror as a rear view mirror in vehicles? You all were confused with respect to this case, right? So the real reason is a convex mirror will give us a wider field of view. Got it? So we use convex mirror as a rear view mirror in the vehicles because convex mirror always forms virtual erect and diminished image. The image will not be inverted. We need an erect image, right? We need to see all the vehicles behind our vehicle, isn't it? And the images should be diminished because all the vehicles should be seen in this small mirror. So irrespective of the distance, we'll get the image diminished. A convex mirror enables the driver to view larger area of the traffic behind it. Got it? That is the reason we have chosen a convex mirror as the rear view mirror of vehicles. For a larger field of view. Correct, Shivanya? So that there will be wider view. Correct, Badra? Very good. Yes. So we'll move forward. A security mirror used in a big showroom has a radius of curvature 5 meters. If a customer is standing at a distance of 20 meters from the cash counter, find the position, nature and size of the image formed in the security mirror. What do you think, guys? Security mirror used in a big showroom. So guys, the security mirror will be convex or concave. What do you think, guys? A big showroom is there. Imagine. Okay. So we should be able to see a lot of people over there, right? Isn't it? So if a customer is standing at a distance of 20 meters from the cash counter, so we have to find out the position, nature and size of the image. So for all this, we need to identify which mirror will be the security mirror. So guys, for security mirror, which mirror we'll use? Guys, think about it. A big showroom area we have to view. For larger field of view, which mirror we'll use? Shivanya, wrong. Bhadra, correct. Convex, right? Isn't it? Obviously, for a wider field of view, we need to use a convex mirror itself. So security mirror used in a big showroom has radius of curvature 5 meter. So guys, if radius of curvature is 5 meter, focal length will be R is equal to 2 times the focal length, that is R is 5 meter is equal to 2F. So radius of 5 is equal to 2F. So focal length F is equal to 5 by 2, that is 2.5 meters will be the focal length. I got the focal length as 2.5 meter because radius of curvature is 5 meter, right? If a customer is standing at a distance of 20 meter from the cash counter, so customer is the object, right? Because the customer's image has to be seen in the mirror, isn't it? So object distance U is equal to minus 20 meters because always object distance will take it as negative. So focal length we got 2.5 meters. So guys, 2.5 meters of focal length we have. Object distance is minus 20 meters. You can either convert this meter value into centimeters and calculate, or else you can keep it in meters and calculate it directly. Your wish. Got it? Yes. So we need to find out the position of the position nature and size of the image. So image V is equal to U into F divided by U minus F. In the last question we did this. We have used this formula. Is it? We have rearranged the equation and found out the values. I hope remember. So U value is minus 20 into F value is 2.5. Guys, focal length of a mirror, convex mirror will be positive. So positive 2.5 divided by U is minus 20 minus 2.5. Isn't it? Not 2.8, 2.5. Okay. So guys, how much you will get? Everyone calculate. This is confusing because you got the values in meters, right? That is why it is confused. Got it? Yes. So values you can calculate 20 into 25, 20 into 2.5. You will get it as 50. So it is minus 50 divided by minus 20 minus 2.5. It is minus 22.5, right? Minus 22.5. So we can consider 50 divided by 22.5. You will get 2.22. So minus 50 divided by minus 22.5. It is positive 2.22. 2.22 meters is the image distance. Okay, so portion of the image we got it. Size of the image, what will have, guys? Always in the case of convex mirror, size of the image will be diminished for sure. So you will be thinking, sir, height of the object is not given. How will we find out the size of the image? You can just write the answer as diminished. Size of the image will be diminished. And nature, what will be the nature in the case of convex mirror? Always vertical and erect. Always vertical and erect. Size will be diminished. Position of the image, we got it already. It is 2.22 meter. Understood, Shivanya? Understood, Hannah? Understood, Badra? Shritik? Everyone who is watching the session, let me know if it's clear for you. Can we move forward? Are we good to go? When you, who was it? Shivanya, when she saw the question, Shivanya was like, so this is so confusing. But right now, what do you feel, guys? You find it easy, right? Not too tough, right? Once you get the concept, once you're on track, because from this one single word, security mirror, this convex concept should come into your mind. Okay? If it's given as dentist mirror, this concave mirrors concept should come to your mind. If it's a rear view mirror, you should think about convex mirror. If it's a security mirror, a convex mirror should come to your mind. So that'll help you for sure. Hannah is like, yes sir. Shritik, yes. Badra, yes. Shivan is like, for real? Yes. For real, understood, yes, great, fine. So Neha visited a dentist in his clinic. So guys, a hint I gave you in the last question. So dentist mirror, which one? You know it already. So Neha visited a dentist in his clinic. She observed that the dentist was holding an instrument fitted with the mirror. State the nature of the mirror and reason for its use in the instrument used by dentist. Which mirror will use, guys? Shrutik is like, facts. Okay, sir. Which mirror will be used by dentist? Convex or concave? What do you think? We have learned it already. Obviously, it will be a concave mirror for sure. So dentist will use concave mirror. So the nature of this mirror is concave type, and the reason for its use in the instrument used by dentist is to obtain an erect and magnified image of the teeth. Got it? So I told you, in the case of concave mirror, there is an exceptional case, last case. That is, if we keep the object within the focus, we'll get an enlarged image. So always vertical and erect image we should get. So in the case, so that's why the dentist will use a concave mirror. Yes, concave. Badra is killing the chat box with 10 E's. She wrote concave with a lot of E's. Yes. Yes, concave, correct. So a concave mirror gives the dentist a magnified reflection. Magnified image we need to know, right? All the cavities has to be identified, right? Dentist should find out all the negative things which we have in our teeth, isn't it? So if dentist is examining my teeth, nothing will be there, but it'll be perfect. But if it's your teeth, you guys don't brush properly, right? So obviously, they need a concave mirror to focus properly, isn't it? Yes, you're bad, correct. This means the image in the mirror is big and brighter, and for the dentist it's easier to see, isn't it? Another positive point of using concave mirror is that the image in the mirror isn't inverted. It won't be inverted in this case, isn't it? If you're keeping the object within the focus, it will be vertical erect image, it will not be inverted. Yes, germs will be there in your teeth, Badra. Correct. Yes, Shivanya, yes. Understood, guys? You will not be getting enough time to write all the points. So what you can do is, if you want to write all these points, what you can do is take a screenshot. So later on you can note it down. Got this, guys? Clear with all the points? Perfect. Perfect. Yes. So we'll move forward. So one last question. This particular question I'll give you as a homework, because till now we have learned a lot of numericals, right? So this particular question you have to try it out. So in this also, what they are asking us to draw a labeled ray diagram to justify your inferences. So ray diagram I'll show you over here. You can take a screenshot of this question. So consider it as a homework for you to try it out after this one shot. Because if you're watching this session, what you have to do after practicing all the questions which we did, after that, this particular one single question, you have to practice it by yourself. Got it? So when is your live class coming up? In between, I'll come up, Shivanya, don't worry. Yes, sir, we need you back. Okay, we'll do maximum numericals. I'll come in between, Badra, don't worry. So guys, everyone, taken the screenshot as a homework? Power packed? Yes. So if you have taken the screenshot of this, that's great. For real, Shivanya, I'll come back someday. I'll take some sessions for you all, don't worry. Shritik, Badra, Shivanya, any doubts, any concerns? Before we wind up the one shot, anyone? Good to go. Can we wind up the meeting? Quick, guys, quick. I'm waiting for you all to comment. Shivana is like, yes, sir. Shivana is like, lol. Laugh out loud, guys. Obviously, we'll plan. We'll plan someday to come. For sure, I'll take some chapter. I'll take some marathon. I'll take some revision if needed. I'll be glad. Okay. So if I come, what will happen now? I'll be trolling you all. I'll be teasing you all. Isn't it? Yes. No, sir. No doubts. Okay. If you don't have any doubts, if you don't have any concerns, we can wind up the meeting. Can we wind up, guys? Are we good to go? So fine then. Thanks, everyone. Thanks a lot. So thanks a lot for asking all the doubts, being active over here in YouTube live, watching my session live. Very good, Hannah. Very good participation, no doubts. So fine then, guys. Very good, Shrithik. Everyone, it's fun. Yes, obviously it'll be fun for sure. So that's all for today, guys. Thank you and have a nice day. Bye bye. See you all.